this video, I'll show you how to scale Oracle Cloud Native Environment version 1.2. We'll describe scaling an Oracle Cloud Native environment. We'll explain the load balancer requirement when planning to scale a Kubernetes cluster. We'll describe the steps to set up new Kubernetes nodes. We'll describe the bring your own option when generating X.509 certificates for new nodes. We'll configure the platform agent on new nodes to use X.509 certificates. And finally, we'll demonstrate using the olcne-ctl module update command to scale up and scale down. Scaling an Oracle Cloud Native environment consists of adding or removing nodes in a Kubernetes cluster. When you scale a Kubernetes cluster, a backup is taken so that you can restore in the event that something goes wrong during the scaling. Nodes that you are adding are validated to ensure all of the required prerequisites are met. Nodes are then added or removed as desired, and the cluster is checked to ensure all nodes are healthy. You do need to plan to scale, meaning you need to use a load balancer option when you add the Kubernetes module to the environment, even if your initial cluster only consists of a single control plane node. We'll now discuss the load balancer requirement when planning to scale a Kubernetes cluster. Planning to scale means that you need to use one of the load balancer options even if your initial Kubernetes cluster will consist of a single control plane node and a single worker node. Therefore, if you plan to scale your initial cluster and add additional nodes in the future, you must use either the --virtual-IP option to designate use of the built-in load balancer or use the --load balancer option to designate use of your own load balancer. If you do not include one of these options when you add the Kubernetes module, you cannot scale this Kubernetes cluster later. The example shown on the slide uses an external load balancer, lb.example.com, and running on port 6443. Also notice in this example, our initial cluster consists of a single control plane node and a single worker node. Again, we're only including the load balancer option because there is a potential that we might need to scale up or add a node to this cluster in the future. For the scaling demonstration, we'll begin by deploying 4 Oracle Linux 8 systems in our cluster. We'll have 2 control plane nodes, one of which, CRM-CP1, will also function as the operator node. We'll have 2 worker nodes, and we'll use an external load balancer. After we get these systems deployed, we'll prepare 2 additional Oracle Linux 8 systems to add to our cluster. One of these will be configured as a third control plane node and one as a third worker node. We'll scale up by adding these nodes and then scale down by removing one of the original control plane nodes and by removing one of the original worker nodes. I've already performed all of the operating system prerequisites and I've installed the required software packages on my 4 Oracle Linux 8 systems. If you need to see the complete deployment, you can view the deployment video shown here. But to keep this demonstration as short as possible, I've also already set up the operator node, set up the Kubernetes nodes, generated and transferred the X.509 certificates, started the API server, started the cloud native agents, and created the environment. So I'm going to begin this demonstration by adding the Kubernetes module to the environment. It is during this step that you have to include a load balancer option if you wish to scale your cluster at some point in the future. I'll use the olcne-ctl module create command. My environment name is my environment. My cluster name is my cluster. Provide the container registry. In this example, I've set up an external Oracle Cloud Infrastructure load balancer. I also provide the fully qualified domain names of my 2 control plane nodes and of my 2 worker nodes. And since I'm deploying release 1.2.2, I need to include the --restrict-service-external IP options. The Kubernetes module is created. To save time, I've validated and installed the Kubernetes module. I now create and export an environment variable, which allows me to run the kubectl command as a non-root user. I can now run the kubectl get nodes command to show that our initial control plane nodes and worker nodes are ready. We'll now discuss the steps needed to prepare 2 more systems to be added to the cluster. On your Oracle Linux 8 systems that will function as the new control plane and new worker nodes, make sure the prerequisites listed in the Oracle Cloud Native Environment Getting Started Guide are met. The systems need access to the required repositories. System time is synchronized across the nodes. Oracle recommends installing and setting up the cronid daemon for this purpose.
Swap is disabled, SE Linux is in permissive or enforcing mode, systems are configured with necessary firewall rules, and systems have the br_netfilter kernel module installed.
You then need to install the olcne-agent and olcne-utils packages and enable the olcne-agent.service.
The script shown on this slide is used to generate certificates. Because we use this script to generate certificates for the original Kubernetes nodes, we can use the same script to set up certificates for the new nodes. The key options when using this script are emphasized on the slide. Use the Bring Your Own or BYO options to specify the location of the existing CA certificate and to specify the location of the existing CA key. For the nodes option, provide the fully qualified domain name of the new nodes. A transfer script is created that you can run to copy the certificates to the new nodes. The transfer script does require SSH passwordless access to the nodes. To set up X.509 private CA certificates for the new control plane and worker nodes, run the gen-search-helper script from the initial operator/control plane 1 node. I'll use the two BYO options, -BYO-CA-cert and -BYO-CA-key to specify the location of the existing CA certificate and the CA key that were generated when I ran this script for the initial nodes in the cluster. For the -nodes option, I'll provide the fully qualified domain name of my new control plane and new worker nodes. I need to transfer the X.509 private certificates to my new nodes. I've already configured SSH passwordless access, so I can just run the script to transfer the certificates. Now I can flip to my new Kubernetes control plane node and configure the platform agent to use the certificates. You then see that the olcne-agent service is started. And I'll flip to my new Kubernetes worker node and run the same command. You see that the olcne-agent service is started on my new worker node. Finally, use the olcne-ctl module update command to scale up or to scale down. Provide the desired control plane and worker nodes. Include port 8090 for each node. Without the --force option, you are prompted to confirm the module update command. The example shown on the slide results in a 2 control plane, 2 worker node Kubernetes cluster. Now we're ready to run the olcne-ctl module update command, which actually does the scaling. I'll switch back to our original operator control plane 1 node. I first want to run kubectl get nodes to show that we have a 2 control plane, 2 worker node Kubernetes cluster. First, I'll run the olcne-ctl module update command and scale up to 3 control plane nodes and 3 worker nodes for my cluster. I'm asked to confirm that I want to do this, so I'll type Y. A backup is taken, and then the update completes. I'll run kubectl get nodes command again and see we now have a 3 control plane, 3 worker node Kubernetes cluster. I'll clear my screen and run the olcne-ctl module update command again to scale down. This time we'll only include control plane nodes 1 and 3 and worker nodes 1 and 3. I'll also use the --force option so that I'm not asked to confirm. I'll run the kubectl get nodes command again and see we have scaled down to control planes 1 and 3 and worker nodes 1 and 3. This concludes the demonstration portion of this video. Oracle provides an extensive number of resources which you can use to learn more about this subject and others. For further information about Oracle Cloud Native Environment training, you can visit the URL shown on the slide. There is a comprehensive Oracle Linux 8 learning path available to support a full range of Linux administration skills for cloud, on-premise, and hybrid users. And follow the URL to the Oracle Learning Library for more videos on Oracle Linux. This concludes this presentation. Thank you for watching.